Okay, good morning everybody. My name is Dave Whiteley from Envisageukltd Limited. Welcome to another of our Friday morning webcasts. This will take about 30 minutes. It's been recorded, and the subject for this morning's webcast is that we're going to run through Inventor Frame Generator and the analysis of Frame Generator. I hope to also give you some tips and tricks as we go through as well. If you've got any questions, my email address is on the screen, and our website, together with our blog, is as you see on the screen as well. Okay, what are we going to do this morning? We're just going to create a simple frame generator assembly. I'm going to go through some tips that I've come across when using the frame generator in Inventor. We'll also work with multiple sub-assemblies. We're not only just working in single assemblies these days, you're going to be designing separate sub-assemblies, placing them together into a GA, and we want to see how this works as well. We're going to run through the frame analysis software that you get with Inventor Professional, and previous releases it was Inventor Simulation. And we're also, whilst we're in the analysis, I'm going to explain how we add extra nodes and rigid links to the analysis for sub-assemblies that we're going to be pushing through to the analysis. For those of you who haven't got Professional and want to do some form of stress analysis on a frame member, then there are other methods that we can use that are available to you in standard Inventor, and I'll go through that at the end as well. Okay, so I'm just going to go into Inventor and start a simple frame generator assembly. The important thing with a frame generator is to always create the following in this order. So we start off with an assembly file, a blank assembly. We then create in here the model that's going to be our skeleton model. I'll explain that in a second as we start modeling it. Give it a name that identifies it as the skeleton part, because this doesn't want to be incorporated into your bill of materials or parts list. And that said, it's important when we do create this in-place component to actually set the default bill of material structure to reference. This does two things. This takes this part out of the bill of materials and parts list, and more importantly, it also takes the mass properties away from the assembly as well, so it doesn't include the weight of this component in the assembly. The other thing that you need to do when creating in-place components in assemblies is we used to say, well, just click on the screen to sketch on the XY plane. The problem we have these days is a lot of people have 3D connection manipulators, and it's good practice now really to select the XY plane from the browser instead to place your first sketch. You know then that for sure that's on the XY plane. Otherwise you may have problems later on when you push this through to a 2D drawing, and we've had instances where the view is not quite flat on the drawing view. Okay, so let's model up our skeleton. Now on earlier presentations from Autodesk, they used to show this as a 3D sketch. I prefer to do it this way, whereby we actually, if I just model up a rectangle, a meter by 500 mil, what I actually do, or prefer to do, is to actually create this as a solid. So model your skeleton as a solid model instead. It's a lot quicker than working with 3D sketches, and we still have the ability of selecting the edges on this model to place our steel sections later on. If you've got any other braces or struts, then you just add these as sketches on the faces. The other thing I do on this is purely personal preference, but I change this to glass so we've got some form of transparency on this skeleton, and I always use black edges for this as well. So there's a very simple meter long 500 by 500 block that I'm going to use as my skeleton for adding my steel profiles. Go back to the assembly. You need to save the assembly. And then we go to the design tab, the design ribbon. And this sends us to the design wizards, and we're going to be looking at the frame analysis section, or the frame design section of this ribbon. Those of you on standard Inventor won't have the frame analysis button here, by the way. There are other options for the frame generator, from this pull down, I'll be looking at the beam and column calculator later on. So what we do is we go to our Insert Frame Member button. We choose our standard that we want to work to. We choose our family, i.e. the section that we want to use. This is just a list of standards. You can use the up and down arrow to choose what you want, and you'll get a preview on the screen here of the profile section. The size, the material, and the colour that you want to choose to use to add these sections by. The dartboard effect here enables you to align either a corner, the centre, or the middle of a face with an edge that we're about to select on the skeleton model. I'm just going to, for the ease of presentation today, just use the centre. We can then jog it backwards and forwards, and also rotate it and mirror the steel section as well. So for C profiles and so on, this will be useful. Last but not least, the placement. By default, it will place the member along the entire edge of the skeleton. If you want to place it point to point, then use the second button along. So if I wanted to use any steel bracing, standard steel section, steel plate in other words, I may want to put a short line or a couple of points on here so I can actually add a piece of steel, standard steel plate to my skeleton, but still do it inside the frame generator. And likewise, things like if I've got tubes underneath for forklifts and so on, I could do the same sort of thing and then jog them down into position using these tools here. Okay, now for the box section, I'm going to use the center to align with all the edges on the skeleton. I'll do that very quickly, but just as a tip really, if you're adding other sections, C-sections, beams and so on, then select the one edge first and place the section, and then get the alignment right by clicking on the relevant buttons here to align it correctly. And then always move off from one end to a line that connects to the edge that you just selected, and just move around and select individually to lines that are linked to the beam that you just selected. The way that works then is it uses the alignment of the first edge to sort out the alignment on the second and third edges that you select. So if I select this edge first and then go to that edge afterwards, it won't get the alignment right on the second edge that I've selected. So always move gently from the first edge to edges that connect to the first one, and you'll get the alignment correct. In this instance, because on our right click we've got things like multi-select and chain select and so on, I can just literally window around the skeleton and add my box section immediately to the skeleton and populate it. So there are two buttons down here that are important to talk about. The first one is to prompt for the file name. Now, what will happen is the steel sections will be given a random numbering scheme to create a part number for the steel section. It will use the ISO description in this case as well as the start of the file name. But if you actually want to be prompted for the file name yourself, so you can put in your own part numbers to these, then tick that box there. The second one is relatively new. This gets the frame member's part number from the content center. Now this is actually very useful if you want to roll up standard lengths, common lengths of steel sections. So if I've got some box section that's all, say I've got 4 of these a meter long, it'll roll these up into the parts list as 4 off a meter long, as opposed to giving these all separate part numbers, and obviously in the parts list you just have one of each. We're asked this all the time. It's quite useful to do this. I would suggest you don't use that button if you're using Inventor Professional with the item master, because that doesn't come through correctly at the moment. Okay, so it's all populated. Let's click on OK to populate the frame. You will be asked for a sub-assembly name and a location, and the skeleton file name as well. I would give these unique names based on the assembly that you're working on. Certainly if you're using the vault, because if you're using the vault and you've got unique file names switched on, then I would suggest you give these unique names based on the assembly, even if it's just a matter of putting base underscore underneath or something like that, based on the assembly we're working on. Okay, so that's the frame generator populated. The actual end treatments I'm not going to worry about at the moment because I want to do the analysis first. But one thing I would suggest you do is turn off the visibility of the skeleton in your assembly. This really does help when you come to select faces inside the skeleton when you're starting to use miter and trim extend and so on. Okay, let's save this. And now we'll put this into a GA. Now I've got, I'll just start a blank assembly. And we'll take this base assembly and just copy that and paste it into our GA. Okay. Now secondly, I've got another sub-assembly I want to place on here, so if you just go to place and put another sub-assembly on here. What I want to do is show you that we can actually work in multiple sub-assemblies and a GA when we're working with analysis software, but there are certain things that you may have to do, which I'll go through when we start running the analysis software itself. Okay, let's assemble this together. I'll use the new assemble tool. This takes away the laborious ticking of options inside the constraint dialog box. All we do is we select a face and then another face. It drags the component on with the cursor as you select the first face. The first face or edge, always select it on the moving part. If I select another face I want it flush to, it will determine that that is flush because of the orientation of the two faces, and I can just accept that, and that's it flushed immediately. Let's make these together. So again, assemble, select the face that we want to mate from, the face we're going to mate to. Again, it determines from the orientation that that's actually a mate and not a flush. And finally, we'll do a final flush between the two end faces here and put that 250 apart. Okay, so there's our assembly. Assembled using the new tools. We'll just to save this. And then we'll go into the frame analysis software itself. Now, the frame analysis software is a subset of Robot, which was purchased by Autodesk about 3 years ago. It's a structural analysis package, and they've incorporated a certain amount of it inside Inventor Professional. If I go ahead and create a simulation, you can see that I can actually create a static analysis or a modal analysis of the assembly. Modal analysis enables me to find the natural frequencies of my assembly, the resonant frequencies, such that if I've got, say, a motor attached to this assembly and it's running at a certain frequency, then I don't want the assembly to vibrate itself to bits if one of the natural frequencies is the same or close to that of the motor. So I can design it out and rerun the analysis again. So that's the idea of using the modal analysis. In this case, I want to do a static analysis. I'll add some forces to the top of the assembly, add some constraints to the bottom, and have a look at the forces in the assembly itself. This then runs through and loads up the robot software. Okay, what you actually get is the centers of the beams are added as beam elements or lines on our 3D model, and the lines themselves, the centers, are then connected by nodes. And the analysis is actually done on these lines. It's not done as you would work with a 3D finite element analysis package. It's all done on these beam elements here. Where the two assemblies connect, we've actually got a rigid link here which connects the two nodes together, so the forces of the one node is transferred to the force of the node below on the other side of the rigid link. The yellow arrow here, which you can just see, is gravity, which obviously in this case is in the wrong direction. So the first thing we would do is we'd actually change gravity, put that in the right direction. Okay. And let's have a look at the materials. So properties first. If we have a look at all the frame members, we've got all the mechanical properties on the screen here, which we can customize should we wish. The centroid, which is used for the beam element, and the geometry and all the mechanical properties. If we want to change the materials, we can do it here. So all the material at the moment is mild steel. There's nothing to stop me customizing this and say, right, okay, well, let's select all these beams and change these to stainless steel, for instance. Let's put some fixed constraints on here. So we'll select the nodes. Let me just change the sizes so you can see what's going on. Okay, we'll add some fixed constraints. To the model. And then finally, let's put this into an axiometric view, it's a bit easier to see. There we go. We'll add a continuous load. We've got force, continuous load, and moment. In this case, I want to add a continuous load to the beam. Here we can give it a start and end magnitude. We can also change the angle of attack of the force and so on, either graphically on the screen or from the dialog box. It's a lot quicker doing this with dialog boxes, so in the frame analysis settings it's a good idea to take off the heads-up display tick box in the frame analysis settings. That gives you a better and easier way of working by bringing up the dialog boxes instead on the software. Okay, so we've now got our loads, we've now got our constraints, the gravity's in the right place. Let's go and simulate this. And the results are available to us as in finite element analysis software, so we get a color bar. We get all our geometry coded, all the beams coded, all the forces, the displacements and so on the 3D model. We have a look at the results. Let's go to normal stress, have a look at the maximum stress, and then in the display we can put on the maximum value on the screen to have a look at our maximum stress. We can also put on the local systems, because when you look at the forces in X, Y, and Z, they're all in relationship to a local coordinate system on the beam. You notice Z is vertical on most of these, but you have to be very careful when you're analysing using forces in X, Y, and Z, because it's all in relationship to these local coordinate systems. But what I'm going to do here is let's have a look at the displacement. We've got quite a large displacement along the beam here, 8.5 millimeters or thereabouts. So I want to change my design and put a bracing piece in the bottom model here. So what I'm going to do here is finish the analysis. Let's go back and edit the bottom frame assembly. Edit the original skeleton model. And we're going to place a sketch on the side of this skeleton and just literally draw a line on the face of that skeleton. Finish that one. Let's turn it around. Sketch on the other side. And in this case I could use project geometry and project the line that I've drawn on the other side. If we wait for the select next to come up, the selection cycle in Inventor 2012 has been improved, whereby you actually get a list of objects behind the cursor, which you can actually select from this pull-down list. It's a lot easier than the icons that we used to have before. That's projected that across to this side of the sketch. Okay, let's return back to the top of the assembly. And we'll go and insert some more frame members to these sketch lines that we've drawn. And then all we need to do now is go back to the frame analysis. Sorry. Go back to the top level assembly. Okay, it's better. Save this. Back to the frame analysis environment. This loads up the previous analysis. And what we need to do now is update this because the nodes, we've got an analysis. Let me just resimulate this. Because we've now got some vertical beams on here as well.
Oh, beam.
Sorry, struts. That now adds a node to this vertical brace here onto the beam that's going along the top. But what I may want to do is add a rigid link between this node and halfway along this beam here to transfer forces from here down to this vertical piece here. So I would add a custom node to this beam. If I edit that, I can then change it to relative so it's halfway along, and then add my rigid link between these two nodes. And then likewise, just do that to the other side. And then add a final rigid link between these two. And then I can go ahead and run my analysis again. And then perhaps publish this out to an HTML document. For a full report, I can choose what analyses I want or what results I want through to this report. It's just taking all the screen grabs at the moment. And that creates us an HTML document with all our equations, results, loads, and so on in the report. Okay, so that's the frame analysis finished. Just to have a quick look at the frame generator, just to finish off. If I take this bottom assembly here, we would probably want to start to work on this analysis, or on this frame. Now we finished the analysis. A lot of companies probably would want to just run and create a quick and dirty frame generator model first, do the analysis, and then afterwards start to trim and extend and miter to create the final design. So just very quickly, we'll just do some mitering on this. You can put a weld gap distance in should you wish. Everything's color coded on the dialog box, so we'll just add some miters. And some trimming. This is where it's useful to turn off the solid of the skeleton, so you can actually pick inside as well. You can multiple select as well, so in trim extend we can actually select multiple frame members. And another useful option, let's turn this around and do one more trim. And then one useful option is what they call trim to frame, where that enables me to select two members, and it does an extend and a trim all in one go. And also with this you can shorten, so if I've got like a plastic cap or something I want to place on the end, I can actually shorten it by a distance as well, so that it does all the relevant trimming for us but cuts back by a certain distance. So that's the frame starting to be tidied up. Once you've got the frame member trimmed, then when you go to the bill of materials, you will get all the relevant cut lengths in the bill of materials that you can put out to your parts list in the drawing. One last thing for those of you with standard Inventor, you'll be pleased to know that there is actually a beam and column calculator. This doesn't need any model loaded in the background. All you do is you select a section, put the sizes in, give it a length. Go to beam calculation. This is where you put in your supports and loads. Or if I just go straight to the graph, I can just literally move my supports. Because by default you get 2 supports and 1 load. You can add extras in the beam calculator tab. Let's double click on this and just change the force. And then we've got a complete set of bending moments, angles, deflections, stresses and so on that we could actually put out again to a report. This is single beam, single strut, but you can do this in standard Inventor. You don't need the Inventor Professional for this. And finally, if you wanted to provide proof of calculation to an external agency, then if you go to Help and search for Handbook, get the Engineer's Handbook available to you that comes with it. If you look at beam and column calculator, we can see the formula used and proof of the formula used against this particular analysis that can be supplied with the results. So that's a look at the frame generator analysis on frames. What I've shown you is that we can, a very simple use of the frame generator with a few tips and tricks, I hope. We've learned ways of setting up the frame generator. We've worked with sub-assemblies. We've used the frame analysis software. We've modified the frame. We've added custom nodes and links. And we've looked at other analysis options that we have available to us if we don't have Inventor Professional. So thank you very much for attending. Have a nice weekend. And hope to see you guys shortly. There's another webcast next week. We're moving on all the way up to Christmas, so keep an eye out for emails on that. And thank you very much for attending.